Hello everyone. We have a problem of indeterminate beam with three joints. There's a fixed support at point A, a roller support at point B, a second roller support at point C, making three joints. And we have a point load and a distributed load and another point load at the end. So that makes it an indeterminate beam. And so we have to calculate the unbalanced moment at point B, unbalanced moment at point B. And we're given the options here. So we want to solve this problem. We can use, instead of using manual hand calculation, we can refer to AISC code. If we look at table 323, you will find diagrams that are specific to a situation in which if you break this indeterminate beam into simple determinate beams, you will find standard diagrams that will tell you the moment in that determinate section. So if we start with point A to B, we'll notice that a fixed support on the left side at point A and a roller support at point B, that give you a propped cantilever. And for a propped cantilever with a point load, the free end moment is given as free end moment at point B with relative to the load along at A is given as P A square B over L square. So that is the formula for finding the free end moment at point B when you have a point load. Now for the right side of joint B, we'll have a distributed load, and the formula to find the free end moment at that point will be free end moment at B considering the load between B and C, which is a distributed load, is given as W L square divided by 12. So in order for us to find the unbalanced moment at joint B, we will have to solve these two formula, and the answer to that, we put them together, and that will give us the unbalanced moment at joint B. So we just go quickly and substitute our values into this formula and solve it. So P in our formula here is 2 kips. It's 2 kips, and A is 12 feet. That's from the fixed support at A to the point of load, and that 12 is squared. You square it, and then B is 8 feet from the point of load to the far end support, which is point B. And that will be 8 divided by the length. The length here is 20 feet. 20 feet, and you square that also. And when you do this calculation, you are going to get 5.76 kip feet. Don't forget, we are dealing with moment, so the unit of moment is kip feet or kip inches. In this case, it's kip feet. And now, what is the sign of this moment? When you look at the diagram again, you notice that you can establish your sign convention. The sign convention you can establish. So this is positive for us. So a clockwise rotation will be positive. Clockwise rotation will be positive. So meaning that this to keep force is making a counterclockwise rotation about B. That will make it a negative. So this is a negative sign here. Okay, so that is done. So we'll go to the second force creating moment about point B, which is the load between point B and C. And it's a distributed load of 1 kip per foot. And so W is 1. That's 1 kip per foot. And then the L is 15 feet, as you can see. That distributed load covers 15 feet length. And that 15 feet is squared. And then you divide by 12. And then if you solve it using the calculator, you should have 18.75 kip feet. And now let's check for the sign using our convention. So this force will make a clockwise rotation about point B, and that aligns with our orientation, and that will be positive. So this here is positive. So the moment, the unbalanced moment at B is going to be the sum of these two values. So you take the positive value, which is 18.75, and then the other value we got, which is negative 5.76. All right. Now the negative is there because it's negative here. Otherwise, if it was positive, you add it together. And so you add it up, you're going to have 12.99, which, if you approximate to the nearest whole number, become 13 kip foot. And that's your answer. And when you go to the options here, discover that B is your final answer. So that's how to solve for the balance moment. Typically, this is one of the first steps you engage if you are using the moment distributional method. That's one of the first steps, but we are not going all the way. We just want to know what the unbalanced moment at point B is. Subsequently, we'll go further to look for the unbalanced moment at point A and point C, and with that we can go further to use the distribution method to solve for the moment along AB and BC, and even at CD. But that will be for a later video. Thank you for joining us. Please feel free to review and let us know your thought on this. Thank you.